Understanding the primary and ancillary controls of single-engine aircraft is foundational to any future flying work that you may pursue. Additionally, any control input has primary and secondary effects that need to be considered. These primary and often unwanted secondary effects should be factored into your control of the aircraft to maintain full authority of the aircraft's behaviors at any time. This video will only introduce the primary controls and flight principles required to operate single-engine aircraft, and future content will cover the different effects of these controls. There are three axes about the aircraft center: the longitudinal axes, the transverse axes, and the vertical axes. An aircraft can pitch about the transverse axes, roll about the longitudinal axes, and yaw about the vertical axes. The respective control surfaces responsible for these movements are the elevators, the ailerons, and the rudder. Lift is a force created when an object moves through a fluid. Let's consider Newton's third law. For every action, there is an equal and opposite reaction. As air particles flow around the upper and lower surfaces of a wing, they are redirected or turned downwards. A reaction force to this change in fluid direction, lift, therefore causes the aircraft to ascend towards the sky, given that the weight of the aircraft is less than the generated lift force. If the speed of the airflow is increased, the amount of generated lift force is also increased. This effect is noticed at lower speeds, such as during takeoff or landing, where controls are less effective as the lift produced by these control surfaces is reduced. We can control the amount of lift generated by the horizontal stabilizer with a control surface called the elevator. This is achieved by controlling the amount of redirected or turned airflow around the airfoil. To pitch the nose of the aircraft up, we pull back on the yoke, which raises the elevator. This reduces the lift generated by the elevator, creating a moment about the center of gravity of the aircraft. Likewise, if we push the yoke forwards, we lower the elevator, causing more airflow to bend around the airfoil, creating more lift at the rear of the plane. This creates a moment which acts to pitch the nose of the aircraft down, as there's a greater force pushing at the back of the airplane about the aircraft's center of gravity. To summarize that, the elevator works to increase or decrease the lift at the tail, causing the pitch of the nose to respond in an opposite motion due to the moment created about the aircraft's center. Similar to the elevator, the rudder works on a perpendicular plane. As airflow moves around the tail, the rudder can redirect or change the direction of this airflow, generating a force responsible for controlling the yaw of the aircraft. This effect results in the airplane's nose moving to the left or the right. The rudder pedals can be located in the footwell of the aircraft. Lastly, we can roll the aircraft in a similar fashion by adjusting the lift produced by each wing using ailerons. When we turn the yoke to the right aileron moves upwards to reduce the amount of redirected airflow in the downwards direction, and the left aileron moves down to increase the amount of redirected airflow in the downwards direction. This generates more lift on the left wing, causing the plane to roll about the longitudinal axes towards the left. The yoke is responsible for controlling both the ailerons and the elevators. In this video, we've only talked about a few effects of these primary controls, the primary effects, as well as what lift is and how it's generated. Lastly, before we finish, always remember to fly safely. The I'm Safe acronym is something you should be thinking to yourself before you fly.